Hi, everyone. Unlike the previous two speakers, I'm going to speak about only one project that I have jointly with EFSEC in the area of microgrid. This project calls for a design and demonstration of a battery integration system with the grid. It's funded by a company, Mensah, and Ajay Mensah is a former student of mine, finished from UCF, and he started a company in New Jersey. And thanks to the Florida High Tech Corridor program, the match program, they really had an opportunity to talk to him, convince him that there is, strong match program if he moves his business here. So fortunately, Mensah is moving a lot of his projects to Florida. And thanks to Jim Fenton from EFSEC, we realized the best way to have that project demonstrated with the kind of energy and power requirement is at EFSEC, and that has been really through collaboration between three entities. And I really appreciate what Florida High Tech did, and Paul Sol has been very supportive to get Mensah moving to the Central Florida area. So the project has two components. The first one is really the design of the controller, and to demonstrate that energy storage with the grid functionality can become a good business model for utility. So this is being done for the utility. They have project funded to Mensah to be able to show a large storage system that can really do the peak demand, address the peak demand issues and improve grid reliability through grid forming functionality. And that will help them to have several years where storage serves to provide the required energy. Second piece, the one component of the system is always inverter design. And this is what our research at UCF in the EC department, we're doing power electronics, where we build an inverter design. So the second part of the system is to build a 3-port microinverter that really has been developed by my Ph.D. students in the lab, that we can demonstrate at least one module part of this project. So the project has two main components. Let me talk about the first part. The first part really is a pilot project that's being done physically at EFSEC with all its components. So this is for a public commission utility in Maryland, and they wanted to show, can we show the business model when you incorporate batteries to the grid and you own the battery system, can it operate by a third party to provide any growth in energy demand, meanwhile address peak demand, as I said, flexibility of the grid, provide all the functionalities to do grid forming, grid following, especially when you start adding PV systems. So the project, fully implemented project has 1 megawatt of power, which is a large inverter or several inverters, provide the energy conversion from the battery to the grid. And then the energy storage 3 megawatt hour system. So that's what's being delivered to Maryland. And at EFSEC, at UCF, we're building half of that system, demonstrated, show the controller design, and be able to provide that to the customer. So later this year, it will move back to Maryland. And then at the end of the day, what we have at UCF is a platform to allow collaboration in terms of a grid, microgrid applications, where storage and PV plays a major role in the project. So what's being done at EFSEC today is one system, part of two systems that will be finally delivered to the utility. The system we're talking about has 500 kilowatts inverter, which is what we call PCS. This is the power conversion system. And then 5 lithium-ion batteries. All of these components are off the shelf, being integrated at EFSEC to provide the output needed to address several grid functionalities. Not only operating battery to the grid and grid battery. The question is, can the controller have PV input when you have other sources of DC loads? Can you integrate them all into one box? So at the end of the day, there is a controller design where all the grid functionality can be addressed while making sure the business model can really work. Means I can own the storage, I can do all the functionalities. So you cannot do that unless you demonstrate it. So that's what we will have, an advanced integrated controller at UCF, and then provide all the features that address the microgrid. And then when you talk about reliability of the grid, under frequency variation, voltage variation, how can you make the grid become formed grid, which means you really stabilize it under all these kind of conditions, and then address microgrid functionality in the absence of the grid, or when you want to work from your battery storage to provide that. You know, this is an important model as we see more EVs are coming to the market and more stress being done on the grid. So a large storage system like this one, 1.5 megawatt hour, can really relieve the grid from a sudden demand for several EV charging requirements that when it comes to the grid. This is a kind of busy slide. This shows really physically what being laid out at EFSEC. So this is the utility connection. It's a 480 volt AC system, 3-phase. And then we need the transformer being interfaced with a very quick disconnect switch. And that AC system goes into the inverter system. This is where the power conversion happened with all its functionality with the DC connect to the batteries. Again, we don't have PV connected. And ultimately, we want to do that with the controller design. So this is the energy conversion bus to the grid. And then it comes from the batteries. There are, at EFSEC today, 5 batteries, each at 372 kilowatt hour capacity. These are lithium-ion batteries. They're all connected to provide a full storage system, the BSEE we talked about, and then get that energy back in the inverter to the grid and back and forth. So this is being demonstrated actually as we speak. So last week they were able to push some power, small amount of power back and forth in the grid. And the controller unit, ultimately, this is what will be delivered. This advanced controller should be able to communicate between the grid, the inverter, and the battery system. And then what if you add PV system? What if you add fuel cell and other storage? The utility now has a very flexible model that serves the customer without really putting the stress on the grid because of EV coming, or you have hurricane coming through and you lose the grid. Can that system be economically viable? So that's what we want to address in this first part of the project. This is a bigger picture of what these are very large, kind of batteries, and they're all connected into one system. And the next month or so, the controller box will be kind of finished with some functionality to the grid, and we will push back energy to the grid at EFSEC and see we can provide some benefits to the grid. Second part of the project is what we call 3-port system. When you come back to this controller, this is multi-port system. How can you have a battery integration, inverter integration, and then you have the PV and other DC sources, and this is all bidirectional. You want to go back and forth in order to address all the benefits or you can handle all the benefits. So what is the power electronics can do that? So we came up with some design at UCF. This is really what my PhD students are working on, a system that integrates several sources, and a PV from renewable, could be fuel cell and so forth, and then tie this to the grid, and then whatever kind of loads you have at home. We call 3-port. At this time, we're only doing 3-port, the PV, the battery, and the grid. You can have multi-port with the same design. We had good results that have been patented by my students. And I think we have a good design with a very high power density. And we're trying to get the cost down and be able to make it really high efficiency. we're talking about high efficiency above 97, 98% efficiency, and then allow bidirectional power flow between the battery and the system, battery to the grid back to the battery, and then from any renewable sources. If you add EV, grid to EV or EV to G to the grid, we can do that. So this design can do that. Part of this project, we will build that box. We're working on it. We need several months to finalize one prototype. We will do probably 2 kilowatt to one system integrated into a larger block diagram. We like modular approach. So our design will have about 10 kilowatt system with storage integrated into the grid. And if we get that box finalized with all the what do we call design characterization met, especially the business model is the hardest. How do we make this economically viable and workable? So this is what we will be doing in the next several months. We have a prototype in the lab, and the prototype, all the initial indications are good, and it's being patented as we speak. Of course, all the work is done by my student and the team from Mensah Corporation. So I want to thank all my graduate students part of this project. Ajay has been very supportive, CEO of the company, very promising business model he has. And I think we'll see more projects coming from Mensah at UCF. And then, the folks at EFSEC, I really appreciate all the work they have been doing. This has been a tough project, given the amount of power and energy being discussed, and how do you do that safely at EFSEC. So with that, I want to always, I conclude with this slide that Thomas Edison, way back in 1930, said, let's look at the sun as a great source of energy. I hope we don't do that when we run out of fossil. Actually, we are doing it the worst way, which is really polluted the air. So with that, I'll stop and maybe take some questions.